Hey guys, what's up? It's your pal Dave from notesandvolts.com and welcome to part 3 of the Teensy-Synth tutorial. Today we're going to turn the Teensy-Synth into a fully playable instrument by attaching a MIDI keyboard. Alright guys, so like I said, today we're going to actually make our synth playable by attaching a MIDI keyboard. Now this is a USB-Midi keyboard and it's the Korg Nano Key 2, but really any USB-Midi device will work. You could even use Ableton or any software to control this as well. So the keys are mapped out. And it goes down to about C0 and up to I think C6. So let's take a look at how it's done. Okay, so the first thing we have to do is open up our pure data control panel that we made in the last tutorial and add some updates. So if you remember, we had a MIDI output object and that allowed us to output these MIDI CC commands to our Teensy-Synth. But now we need a MIDI in object as well. So let's create one of those. So first we'll go to the put menu and we'll select a new object. And we'll just put it above our MIDI out. And just type in the name MIDI in. And then click to the side and you should get this object here. If you get the little handles, you'll know you did it correct. So we'll just line this up to the side. And then we'll connect our MIDI in to our MIDI out object. And that will basically pass through any MIDI in commands that the pure data program receives and pass them on to the MIDI out, which our Teensy is connected to. Now we're going to add another cool function to this. So if you remember, we had two oscillators and a noise oscillator. So what I thought would be cool is we're going to make one of the oscillators selectable as far as octaves go. So to do that, we're going to get a new type of object and it's going to be a V radio. Now this is just a vertical radio button, and a radio button, as you may know, is just a button that, or a group of buttons that can only have one selected at a time. So let's go back to edit mode. So remember, you have to be in edit mode to edit your panel. And if we click on the radio and go to properties, we'll get some properties for this. Now first of all, we're going to set this so it has five buttons. All right, just like that. And we can also add a title on top. So I'll just call this octave. And you notice it's a little off-centered. So what we can do to fix that is just offset it on the x-axis. So I'll type in x6 and you just have to kind of experiment. That's actually could be a little more. Let's go -8. And that looks pretty good. So we'll just apply and then OK. Now here's our 5-position radio button. Now the next thing I'm going to do is get a number object and attach that. And finally our control out object. So we'll put an object. And they automatically connect it. If they don't, just remember you just have to draw a line from one to the other. And remember, this is going to be our MIDI CC controller. So we'll do CTL out, and we've done controller number 100, 101, 102. So let's just make this 103. And there we go. So that's our new control. And if you look, if I go out of edit mode, when I select the different boxes, you notice the number it puts out is 0 to 4, right? So the controller number is 103, and the value it's putting out is 0 to 4, depending on which button I'm pressing. Whereas if you remember, our sliders put out 0 to 127, which is the full MIDI range. Okay, but that's really all we need with this. Now, to make it even a little more friendly, we're going to put some labels. So let's go back to edit mode, and we'll go to comment. All right, and we'll just stick that right there. And if you type in the comment, we'll call this +2. All right, so I'm going to have octaves from +2 to -2. And I can just go edit and I can duplicate that. And let's just duplicate 5 of those. And just kind of try to arrange them as best you can. And then we'll type in the values. So this will be +1 octave. This will be 0 octaves, or the actual pitch. This will be -1 octave, and this will be -2 octaves. And if you have OCD, this program's a little a little tough to deal with, because it's hard to kind of get everything exact, but if you kind of mess with it, you can get things roughly in place. All right, there you go. So we have our labels, and just to make things complete, we'll label our faders as well. Remember, this is the mixer section of our synth. So we'll hover over the object, right click and select properties, and we can add a label. Let's just call this noise. And once again, it's not really lined up, so we'll do our little offset trick. If you just kind of hit apply, you can get it where it should be. All right, that looks pretty good. Okay, so let's label this. So we're gonna go properties, and we'll make this oscillator 1. And once again, we'll have to do our little offset. So let's try -6. That looks pretty good. And we'll make this oscillator 2. All right, that looks a lot better. Now just make sure you get out of edit mode, and now you should be able to play with all the sliders and buttons and see the numbers change. And if that all works for you, then we are done. Okay, so the next thing you're going to want to do is follow the link in the video description and download this program. So this is the part 3 of our TEENSY-Synth project. It's the keyboard test, and it basically uses the exact same components that we used in the last tutorial. So I didn't change anything there. We've got our 2 oscillators, our pink noise oscillator and mixer, and our output. Here's where we change things. So if you remember last time, we had our USB-Midi set handle control change, and that's how we changed the level of the oscillators with our mixer in Pure Data. Now I've added 2 more commands here, and this is really how the USB-Midi library works on the Teensy. So if you notice, this is called set handle note off, and this is called set handle note on. Now what that means is whatever this name is, so right now it's my note off and my note on, that's the function that will be called when a MIDI note is received or a MIDI note off message is received. So once you've set that, the MIDI library will know which function to call when these events happen. So now we've got one that handles control change, one that handles note on, and one that handles note off. So let's take a look at those functions. So we'll start with our note on function. So here's the note on function, and this is how you set it up. So it's a void function. That means it doesn't return anything. Here's the name. It has to match our command that we set earlier. It has to be exactly the same, and it has to take 3 bytes. One is the channel byte, so that's the MIDI channel, which can be 1 to 16. It has to take a note byte, which is what note was pressed on the keyboard. And those numbers can be 0 to 127. And also a velocity byte, which is how hard was the key pressed. So some keyboards respond to velocity and some don't. This one does, so the harder you hit the key, the higher this velocity number will be. And once again, it can be 0, which is no velocity, to 127, which is full velocity. So once the MIDI library calls this function, it's going to pass those 3 values to it. So the first thing I'm going to do is check that the note is higher than 23. And I think that's a C0 in MIDI. And I want to make sure the note is lower than C108, which is a high B. Now what I found is if I go below that C0, it just turns into mush. And if I go above 108, I just get a bunch of aliasing effects, and it doesn't sound too good. So I found this to be a nice musical range. So that's why we're going to confine our note into this range. So if the note matches these parameters, it's between these 2 parameters, it's going to continue. And what it's going to do is it's going to store the note value in a global variable called note. And it's going to store the velocity value in a global variable called global velocity. All right, and I've defined those variables here. Now, if you don't know, global variables are variables that are usable by any part of the program. Now, you need to be careful with these because any part of the program can change them. So you have to make sure you keep track of which functions are changing them and which don't. Now I find using these global variables makes the program a little simpler in this case because I may need to access this information from many different functions, and it just makes it a little simpler. Now the next thing our note on function will do is going to call another function called keyBuff, and it's going to pass 2 values to it. One is our note, whatever note was sent to this function, and the other is the value true. So let's take a look at what that means. So if we go down to our keyBuff function, you notice it's taking two values. One is the note, and one is the true-false setting that we sent, which I'm calling play note. So this function is what we call a key buffer. And before we go into the details, let's take a look at why we actually need this. Okay, so the reason why we need a key buffer is, if you think about it, say I play a note on the keyboard. So that will send a note on command to my program. I'll hear the note. When I release the note, it will send a note off command and the note will disappear. But what if I hold down a key, so the note should be sounding, and then I hit the next key? So now my new note will be sounding, and then when I release this key, I should get this note back, but it won't happen. So since our synth can only play 1 note at a time, as soon as I hit that new note, the old note is gone. So if I try to do a trill or something, it just won't work. So that's why we need a key buffer. Now a key buffer in our program is basically what we call an array. And an array is an object that can hold a list of variables. In this case, we can hold 8 variables, and they start from 0 and are numbered up to 7. All right, so here's how the key buffer works. So when I play a note, it's going to put the value of that note into the first slot. And then when I release the note, it's going to take it out. And there's no more notes to play, so we're done. We got silence. So let's try this. So I play the first note. I'm going to put the value into slot number 0. Still holding that note, I play the second note. We're going to put that into slot number 1. Now, when I release this note, I'm going to remove it and then replay this note. So the buffer is going to check and say there's still a note in here, so I'm going to re-sound this note. So I'll get my original note back, and then when I release it, it will take that out. It's empty. We're done. So our buffer is pretty smart, and it uses something called last note priority. So that means if there's more than one note in the buffer and one gets removed, the last note that was entered is going to be resounded. So let's take a look at a little more complex example. So let's say I'm going to play 4 notes. So 1, 2, 3, 4. All right, so the 4 notes will go into the buffer in order. So for this example, say I have my 4 keys. Let's say I release key number 2, and I'll remove it. We're going to shift these 2 down, and this is my last note. So if it needs to be resounded, it will. I'll release 1 more. Squeeze everything together. This is my last note. This is the one that will be sounded. And finally, let's release this first note. All right. Shift everything down. Resound this note if necessary. And then I'll release this, and we're clear. So that's basically how the buffer works. Okay, so with that in mind, let's take a look at the actual buffer function, and hopefully it's going to make more sense. So like I said, the buffer takes 2 parameters. One is the note number, and the other is a play note, true or false. So that's going to tell this function whether the note is being added to the buffer or whether the note is released and should be removed from the buffer. So if it's true, add it. If it's false, remove it. Now we have 2 static variables. When I call a variable static, that means it's going to keep it. Even when this function is done, it's going to keep that variable as it is. So I can keep track of stuff in a function. So the first thing we're doing is we're making our array. And we're making a byte array, and we're calling it buff. And the number of cells is buffer, which is a global variable that you can change if you want to. So I set it to 8. So that means I could play 8 notes and they will go in the buffer. If I try to play 9 notes, the 9th note just won't sound. But I doubt anyone's going to play more than 8 notes at a time on a mono synth. So that hopefully should be enough. Okay, so we create our buffer and we have a counter which tells us how many notes are in the buffer. So right now it would be 0. So when a note comes in and the play note variable is true, so that means the note was played, it's going to be captured by this if statement. So if play note is true and the buffer size is less than 8, which is the maximum we can have. So let's ignore this play. This is actually going to play the note, so we'll ignore this for a second. So what it's going to do is it's going to take our buffer array and put that note in whatever buff size is. So if it's 0, it's going to put it in our 0 column. If there's already a note there, buff size will be 1, and it will put it in slot number 1. But it will put that note into that slot. And then it's going to say, okay, there's a note in the slot we've got there, so we're going to increase the buffer size by 1. And then we'll jump out of this thing and go back to our main loop. And on the other hand, if this is called and its play note is false, that means I've removed a note. I've taken my finger off. It's going to ignore this and go to the remove note. And that's basically saying if play note equals false and buffer size is not 0. So if buffer size is 0, that means there's nothing in it. There's nothing to remove. It's going to search through the buffer until it finds the value of the note that came in. So once that note is found, it's going to remove that note. It's going to close that gap. Remember, we saw the gap closing thing. That's this thing here. It's going to decrease the buffer size variable to indicate that that note is gone. Then it's going to check if buffer size is not 0 yet. That means there's still some notes sitting in our buffer. We're going to replay the highest note in the buffer, which will also be the most recent note in the buffer, and that's our last note priority in action. And if that's not the case, if buffer is actually 0, that means everything's out and we'll just stop the oscillator. Hopefully that makes sense. If you kind of go through it, it's pretty straightforward, but just keep in mind this example and how the buffer is supposed to work, and also the concept of last note priority. Okay, so you may have noticed we've got this buffer thing worked out, but we haven't actually made any sounds yet. We haven't changed an oscillator, we haven't started anything, so we're not hearing anything yet. And this is what the oscplay function does. Before we look at that, here's an important thing. So up in our global variables, you've noticed I've made this note frequency array, and it's of an array of floats, right? So that means variables with a decimal place. Every key that MIDI can accept, I've figured out the frequency in hertz for every note. So the lowest note we have, which I believe is C-2, is 8 hertz, which is extremely slow. And as we go up, you see the notes are getting higher, so we're up to 25 hertz. It's a very long array, and we're getting up into the thousands now. And when we get to the top, we're up to 12,000 hertz, which is a very high note. So this is how we're going to figure out what frequency to tune the oscillators to for each key on the keyboard. Let's go to our oscplay function now. When we hit oscplay, it's going to take one parameter, which is the note number. And all we're going to do is we're going to take the first waveform and set its frequency to our note frequency array, which is the same value as the key that was pressed. So let's say that key number 22 was pressed, right? So this is going to go up to our array of frequencies and go up to the 22nd value in this list, and it's going to set that oscillator to that note. So this is a very fast way to do it. We don't have to do any calculations of what the frequency should be. We just look it up in the table. Now, waveform 2, if you remember, we can tune it to different octaves. And this is what this octave parameter does. So we're going to take it, the note value plus whatever octave we set. So if we go down to our control change function that you remember from the last tutorial, I've added this case, which is if it receives controller value 103, which if you remember is what we set for our octave selector. So if that is 0, it's going to set a variable called octave to 24, which is 2 octaves, right? Because an octave is 12 notes or 12 semitones. So it's going to set it to 2 octaves, which is plus 24 semitones. If I set this to 1, it's going to set it to this variable to 12 semitones. If I set it to 0, it's going to be 0 semitones. And if I set it to -1, it's going to be minus 12 semitones, and -2 will be minus 24, or 2 octaves down. So that should make sense now. So it's going to play the note plus, let's say if I select plus 12 semitones, it's going to select the note value, which we said was 22, plus 12. And that's what it's going to do. It's going to find the 22nd note in here and then go up another 12 notes. And then that's how we find the frequency for that second oscillator. All right, so now that we've set the frequency of our oscillators, we have to set the amplitude of our oscillators, or how loud they are. And we're going to do that from our velocity variable that was saved when the note came in. Now, this is going to go back to the last tutorial where we talked about scaling an input into an output, which I said was going to be a very important topic, and it is. But one thing to notice is I've kind of optimized this function a little bit. So I'm basically got my velocity, my MIDI velocity, which is coming in, which is 0 to 127, and I'm multiplying it by this thing I called a div 127. So what the heck is that? Okay, so let's briefly go over this concept again because it's very important and we're going to use it all the time in our synth. So the concept of taking an input, which in our case is a MIDI input of 0 to 127, and scaling it into a desired output. So if you remember the formula, it was the input number, so that's the number we get in, 0 to 127, divided by the maximum number we can have, which in this case is 127. And then to scale it to our output, we would just multiply that by our desired output range. So whatever this number is, it's going to take our input and scale it into our output. So let's just say my output is 2000. Okay, so that's the range. I want my output to be 0 to 2000. My input is going to be a MIDI signal, which is 0 to 127. So I get an input number, which say is 64, right? So I'll take 64 divided by 127, and that's going to give me 0.503, and I'll round that up to 0.5, right? And if you know about percentage, that's 50%. And then I'm going to just take my output number, which if you remember was 2000, which is the highest output I want to get, and I'll multiply it by 50%. And that will give me 1007 point something something that I'll round to 1007. So, you know, that's approximately 50% of our output for 50% of our input. Now, one thing to keep in mind about microcontrollers and the Arduino-based controllers in particular is that division is the slowest thing you can do. And that's because the microcontroller in an Arduino doesn't know how to do division. It has no division commands built into it. So in order to do division, it has to call a little software program to figure out how to do division. So that makes it much slower. So in order to optimize our code, we want to figure out a way to get rid of this division. Another way I could write this is I could take my input and multiply that by 1 over 127. And you may look at that and say, you know, but we still got a division. That doesn't help us at all. Well, here's what we can do. This division is always going to be the same. As long as our input number is the same, this is always going to be the same. So let's just calculate it once and store it in a variable and then never have to calculate that division again. So if I do this division, right, I get 0.00, we'll call 78. So we'll stick that into a variable and we'll call it, how about division 127. So when a new input comes in, I'll just take the input and multiply it, which if you remember is much quicker, by our new variable, which is div 127. And that will give me the same as this. And that's basically what I did in the code. So if you go up to our global variables, I made this constant float. A constant variable means you cannot change it. And here's that division. So div 127 equals 1 divided by 127. And that's going to store that result in there. So if we go back down, here you go. Here's our global velocity, right, which is 0 to 127, times our div 127, which will give me the percentage. What about our output number? The amplitude of the waveforms in the Teensy-Synth can basically have a value of 0, which is off, to 1, which is full, which is exactly what this will give us. Our output, our maximum we want, is 1. And as you know, 1 times anything is just the number. So we don't need this, right? So all we need is our input divided by this, which we've simplified or made quicker by pre-calculating that division. So it's doing the same thing we did before, right? That same formula, but we made it a little quicker by getting rid of the division. All right, so now that we know that, let's take a look at what's going on. So we're getting our velocity, which is the velocity of the key that was hit. It's going to be 0 to 127, depending on how hard you hit it. We're going to times it by that div 127, which will give us a value of 0 to 1. We're going to store that answer in this float variable, which I just called velo, which is short for velocity. And then I'm going to set the amplitude, or how loud waveform 1 is, by that amount. And waveform 2, I'm also going to set it by that amount. And the pink noise, I'm also going to set it by that number. Compared to that, the oscillator stop is a very simple function. All it does is it sets all the amplitudes of all the oscillators to 0, or shuts them off. So that's how we stop the notes. Now, you may also notice I've changed our mixer controls, which, if you remember, is the level. I've updated those to use our new streamlined no division calculation. All right, so enough theory. Let's actually upload the code into our synth and get it to make some sound. Go to the link in the video comments and download the software. You're going to get 2 files. One is the program file, one is the pure data panel that we just made. Open up the Arduino software, plug in your Teensy microcontroller to USB, and if you remember, we need to go to the Tools menu and set the type to Teensy 3.2. The USB type has to be set to MIDI because we're making a MIDI object, and everything else you can leave the same. So once you've done that, go to the upload button and press it. All right, so once the program compiles, your Teensy loader program should pop up, and you notice it sent everything to the Teensy without any problems. So if it says the Teensy didn't respond, you have to push the white button. But this time it went through fine. Now, once the program goes in, you should hear this tone, right? And I left that in just so you know that the Teensy is actually programmed. It's putting out audio. Remember to connect it with an audio cable to a mixer or speakers. Now, what you need to do is unplug your Teensy and reconnect it. You need to do this because Windows will not recognize it as a MIDI object until you restart it. So make sure after you program it, you power it down, repower it up. Okay, so now once that's done, make sure your keyboard's also plugged in. Open the pure data file. Go to Media and MIDI settings. Now right now we have no input or output device, so for our input device we're going to use whatever your controller is. So mine's the Nano Key 2, and our output device will be the Teensy MIDI, and that's our TEENSY-Synth we just created. Once you got that, apply, OK, and enable the audio. It should respond to your keys. Now you can experiment with the octave and the mixer. So let's take the noise down, turn the oscillators up full, and experiment with our different octaves. hear the effects. Alright, so everything seems to be working. So if you got this far, congratulations. Alright guys, well that will do it for this time. Stay tuned for the next installment where we'll continue this project and add some more features. Once again, I'd like to thank my patrons. They appear on the screen back there, and welcome my new patrons that joined since the last video. So I hope you're enjoying this series, and I'll see you soon with part 4.